All right, we're going to take a look at how to do a titration now. The purpose of a titration is to find the unknown molarity of an acid or a base by titrating it with a known molarity of the opposite of it, either a base or an acid, okay? So what we're going to use is we're going to use a burette, which is one of these long glass tubes, okay? And it's got a little stopcock on the end, and you can turn this, and when you turn that, it's going to let liquid come out and all that fun stuff, okay? So what we're gonna do is I would have an acid in this, okay, in my Erlenmeyer flask. I'm gonna have an acid, and it's gonna have an unknown molarity. Okay, I'm gonna know the volume because I can measure it in a graduated cylinder or something like that. I'm gonna know the volume, but I'm not gonna know the molarity. Okay, so then what I can use is I can use my burette, which has numbers on it. Okay, you can see the little numbers on here, maybe. Well, just trust me, there's numbers on it. You can see the numbers on the burette, and so you can have liquid in here, and then when you turn this on, you're going to add an amount of base. Okay, so you may have added this amount of base. Well, if you know the molarity of that, then you can end up using that to calculate the unknown molarity. So, what we're going to do is we're going to turn on the burette. We're going to let it come in dropwise into our acid, and this has to have an indicator in it, generally phenolphthalein. And so what's going to happen is that this is going to drop, and we're going to get to a point where this is going to turn pink. Okay, and it's going to start off with little flashes of pink, and we're going to shake, and those flashes of pink are going to go away because they're going away. Okay, um, so eventually there's going to be a point where you add one extra drop, and that one last drop is going to turn this into a faint pink color. That's what you want. That's called the equivalence point. That's when the solution has been neutralized. Okay, if it's an acid that we started off with, then you've neutralized it with the base. Okay, at that point you've also reached the end point, which is where we're going to stop the titration. So now we have our unknown molarity. We have the volume of our acid. We know what acid we were using. We have our molarity of our base, our volume of our base, and we know what base we were using. So when we have all of that information, we can plug all of that into this formula, which is a modified form of our Voom-Voom equation. So if we check this out, we can see that I have the number of hydrogens equals the volume of the acid times the molarity of the acid equals the volume of the base times the molarity of the base times the number of hydroxide ions. So what I can do now is I can plug this, I can read my question and just plug it right into the formula. So if 45.8 mils of a 0.5 molar solution of calcium hydroxide is required to titrate 25 mils of HCl, what's the molarity of the HCl solution? So let's find out our number of hydrogens, our volume of our acid, and our molarity of our acid. We're also going to find our number of hydroxides, our volume of our base, and our molarity of our base. So the acid that we're using is HCl. How many hydrogens are on HCl? There are one, or there is one. There's one hydrogen. The volume of our acid tells us that we're using 25 milliliters. So 25 milliliters of HCl. And our molarity is unknown. That's what we're looking for, okay? But we have titrated it, meaning that we've turned our little base on from our burette, okay? And we've added 45.8 milliliters from our burette, okay? That's how we know how much we added was from the burette, okay? So I added 45.8 milliliters of calcium hydroxide, and calcium hydroxide tells me that I have two OHs. And I know that the molarity of that base is 0.500 molar. So now I get to plug and chug. So I'm going to plug right into my formula. 1 is my number of hydrogens. My volume of my acid is 25. And my molarity of my acid is unknown. And that equals my number of hydroxides, which is 2, times my volume of my base, which is 45.8, times my molarity of my base, which is zero point 0.5. The 1 cancels, of course. If I'm trying to get Ma by itself, I'm just going to divide both sides by 25. And so now I can type this into my calculator to get my final answer. So I'm going to do 2 times 45.8 times zero point 0.5 and hit enter. And then I'm going to divide that by 25. And I get for my answer that my molarity of my acid equals 1.8, 1.83 because of sig figs. 1.83 molar. So go ahead and try example 13-39 on your own. And I think that you should be able to handle titrations. Thanks.